In this video that I've just called Pythagoras' Workout with Brendan, the learning outcome is how Pythagoras can be useful when we've got some challenging situations in the exam, and for you to be mindful that there are often different paths to a successful solution. The solution I'm using here is almost exclusively using Pythagoras, but there are other ways of doing it. The theorem of Pythagoras states that in any right-angled triangle, here I've got PQR, it's the right angle marked, that PR is equal to PR squared is equal to RQ squared plus PQ squared. And most people will be very familiar with that. And in English, the square of the hypotenuse is equal to the sum of the squares of each of the other two sides. A critical piece of information from my point of view is, remember page 16 in the booklet of formula and tables, shows you this: c squared is equal to a squared plus b squared. And that's the famous theorem. What I've got here is just a straightforward, simple example that you would be well familiar with. A bookshelf is 225 millimeters wide. The end is supported by a metal bracket that is 265 centimeters long. How far below the bookshelf is it to where the bracket is attached to the wall? So you're looking for this distance here. So we're just using Pythagoras on it. Let k equal the required distance. That's this here. This here is 225. This is 265. And Pythagoras would say 265 squared equals 225 squared plus k squared. Use your calculator to multiply them out and subtract 50,625 from both sides. Hit your square root button. And just to be sure, maybe just make sure you have the units down. They're millimeters. Really nice, simple, straightforward question, just to set us up. And just virtually, I suppose, immediately here, I'm into what I'm calling the main event. And the main event here is just, if you look, you'll see what was almost a complete triangle with a triangle cut out of it, maybe. So it just says A and B are 2 points marked. This here is the symbol for 90 degrees. Let's read the words. A right-angled isosceles triangle. Wow, isosceles, that's a sneaky word. With an area of 8 square meters, this is cut from another right-angled isosceles triangle of area 72 meters squared. Calculate the distance between A and B. Give your answer correct to 3 decimal places. This is a big hint here. It means that the answer isn't very nice, which is okay. When you read this question, if this is an exam question, this could be so badly answered. So many people just won't get off the ground at all. But what I need you to be able to do here is to look at it and not be afraid. Right-angled, 90 degrees, isosceles triangle with an area of that. If it's right-angled, then I could use half the base by the perpendicular height. They're looking for this distance from A to B here. But there's an awful lot of water that needs to flow under the bridge before I can get to that. So that's the question and the picture with it. So if I turn the page, here's me getting ready to set this question up. And what I decided to do was give this point a name. This already had a name. Give this one a name. Give this one a name. Give this point here a name. And this one already had a name. And also, too, I was very, very energetic. I joined that up there. And when I joined that up, the act of joining this up is great help to me now. I can see there's a lovely little right-angled triangle here. And that's isosceles. I'm going to come back to that in a minute. And then I've got QPB as a huge, big right-angled triangle as well. But that's me being very brave. I'm just completing, if you like, this little triangle here. Okay. Now, what I'd like you to notice as we go through this is that I'm fairly energetic in that I've drawn this picture every time. And to start with, I'm looking just at this triangle here in red. And it's isosceles, which means that angle is equal to that. It also means that this side is equal to this. That's pretty impressive from my point of view. So what I'm saying is that if you look at this triangle SAP, the area is a half the base by the perpendicular height because of the right angle. It's a half of SA times AP. And because I'm kind of slick, I know that that's the same as AP squared because SA and AP are the same. This is the same as this. The area of SAP is 8. That was given. So compare them. So you just compare this with this. And what have I got? I've got a half AP squared is equal to 8. Double both sides, I got AP squared is equal to 16. And if you take the square root of both sides, I have AP is 4. Now this is brilliant from our point of view. This bit is 4, this bit here is 4. I can start to get a bit excited maybe. I have got one bit of a distance. Off I go again, and I just have the picture just redrawn. And I'm looking at this huge big triangle now, this colossal right angle triangle. It's isosceles. Okay, which is really, really, again, incredibly useful. But I've been here before. Those two angles are equal. So I know now that the area of this triangle is 72. That's given. But the area of a right angle triangle, and here I've used the other notation for right angled, is a half the base by the perpendicular height. You have to turn that on its side to see it, because this up here was 90. You were told that in the question. So a half the base by the perpendicular height. A half of QP times PB. But because these two sides here, QP and PB are equal, then it's just a half of PB squared. And then it's very familiar, I hope, because I've got a half of PB squared is equal to the 72. Okay. Double both sides, PB squared is equal to 144, and then take the square root of both sides, and I've got PB is 12. And this is really exciting now, but for me, I just want to jump around to here and say to you, if you look at that, this is 12. And not only is that 12, this one's 12 as well. Okay, that was great. We also have found this here to be 4, and this here to be 4. And what you'll notice is we have just begun. We're a long way from calculating the length from A to B just yet. But what I'm looking at now is I'm looking at P or B. P or B. And this is an isosceles triangle. Wow. How did I know? And this is kind of sneaky. I have it there, and I have the why word written down. And in this, I'm kind of driven here a little bit, because I have to just talk to you, let's say, about the little triangle in there. That was 90. And I didn't mention this on purpose, is that this angle we knew was equal to this one. But not only that, the three angles in a triangle add up to 180, which means that if this one is 90, these two make up 90 and they share equally, so they're both 45. So this one here is 45. And that's where I write the wow word, because the 45 just seemed to come out of left field. And like I say, really, I had that kind of bee in my bonnet. I thought I won't tell them that till it's absolutely necessary. Some people may have noticed it already, but we knew this one was these two are equal. The same logic will apply. That's 45 and that's 45. But because that's 90, then we're in business here. So this shaded triangle now is isosceles. So P or B is isosceles. P or B. And Pythagoras says that if you take PR and square it, and take BR and square it, it's the same as PB squared. So PR squared plus BR squared is equal to 12 squared. But PR and BR are equal. You can see that one's equal to that because it's isosceles. So you get 2PR squared is equal to 144. Divide both sides by 2 and take the square root. If you're some of the cool people, hopefully you might be, then if you hit the square root of 72, you'll get 6 root 2. This is called surd form. I'm not too worried about that, but I'd be happy if you had the 72. So let's go back here for a minute. We knew that this distance was 12. We knew this distance from here to here was 6 root 2. We knew this bit here was 4. And all the while, I haven't gone near the AB part yet. And as I said right at the top of this is not the only way to do it, but I like this here because if you look, PR is from there to there, it's equal to PA plus AR, PA plus AR. So PR is that distance, which is 6 root 2. We've just found it on the last page. PA is 4. We found that like 2 years ago when we started this question. And then AR is this bit here. What's Brendan doing? I don't really know, but I'm going along with him for a minute. So 6 root 2 is the whole thing, equal to 4, which is this bit, plus AR. So if you subtract 4 from both sides now, you'll know what AR is. AR is a rather horrible length, 6 root 2, take away 4. And now I can finally say to you, I am ready. And here I am with my last right-angled triangle, and here it is this time. Now, what I don't like about my solution is that it's really effectively the first time I joined A to B. It's kind of sneaky there. There it is. I'm trying to find that distance. But if you look at this little triangle, wow, yeah, Brendan found 6 root 2. That was okay. This was a monster to try to find, but we found it. It's 6 root 2 minus 4. Pythagoras one last time, and we're out of here. So if we look at this, then AB squared is equal to AR squared plus BR squared. So AB squared is equal to, what's AR? 6 root 2 minus 4. That's going to be calculator work in a minute. And 6 root 2 squared, that's calculator work for me as well. When I add them up using the calculator, I get AB squared is 92.11774. Hit the square root, and to 3 decimal places, 9.598. Exam focus. There are more efficient solutions. However, genuinely, I'm on the Pythagorean buzz here, and I never mentioned the cosine rule, and if you saw that and it's quicker, well done you. I applaud you. Thank you.